Hello folks, I'm back with part 4, which is looking at linear fit and kind of why I use it. But before I go there, I want to clarify something in part 3 that I've caught myself when I watched that and reviewed it. I caught myself using undersampling instead of oversampling. And the problem that I have with my camera combination is one of oversampling. So I probably should go back and edit that video, but just bear in mind, if your camera's pixel size relative to your telescope creates a situation where your stars are really pixelated and look very blocky, where 1 or 2 pixels comprise the star, and in some cases 1 pixel is a star, then you probably are oversampled as well, and drizzling can be a big help. But today we're going to look at the use of the tool process linear fit, and really kind of why I use it. It is very optional. I think your workflow would be just fine if you didn't use it, because I sometimes skip the step, but more often than not, out of habit, I will go ahead and run linear fit, and to help balance out and equalize the HA, the O3, and the S2 luminosity. So this is the process that I use. Let's go to PixInsight, open it up, and let me first share the screen so you can see it. And alrighty, we are looking at PixInsight, and what I want to do is I want to bring up I've already ran linear fit on those three, on the HA and S2 and the O3. So, but what I want to do is I want to load these, and these are our 3 originally drizzled images with nothing done to them. I'm going to run a stretch on the S2 and a stretch on the oxygen and a stretch on the hydrogen alpha. And then I want to show you the effects of running linear fit. I'm going to bring up the histogram transformation tool, and the first thing I'm going to do is I'm going to select a view where I bring up my HADR, and that's this view right here. And I'm going to I'm going to zoom into this a little bit, and so you can see the levels of luminosity as represented by the spike right here. Come down some, and then if I go to and pull up the oxygen, I get a different level of luminosity, and if I pull up still the S2, I get even a different level of luminosity. And what I'm interested in doing with linear fit is creating equal levels of luminosity across the all 3 channels. So we can put that aside for the moment, and I'm going to go to process, image inspection, and I'm going to go pull up statistics, and I'm going to be looking at the mean, and I'm going to put the HADR first. It doesn't matter which one you use, and remember that the mean for this is 5.7 with an exponent of 0.3. So 5.7 is HA, 0.3 is 8.03, so still the smaller number is the 5.1 for the HA, and the S2 is 4.0. So the S2 has the, and it doesn't necessarily surprise me, but it is the baseline baseline color that we're going to use and apply a linear fit to the other two channels. So I'm going to bring up linear fit. You can go to processes, all processes, and go down here to linear fit right here, but I have it saved as a process icon, and if you want to save it as a process icon, then you can just drag the I'll show you right here, just drag this triangle to your desktop and give it a new name, set identifier, and you can call it whatever you want. I obviously have it saved, so I don't need it, so we'll delete it. But I'm going to load S2 because I'm going to conform the other two colors to S2, and then I'm going to take the HA data and I'm going to drag the process on top of the HA data, and we'll give it a minute. May give it longer than a minute. Something I've noticed, and I'm sure it's my 5-year-old iMac, but with some of the recent upgrades in PixInsight, some of these processes that were pretty instant a few updates ago seem to be taking a little longer time. Okay, we are finished with the HA. I'll put this up here just for a moment, and then we're going to apply this to the OIII. We don't need to apply it to the S2 because that's already the we have less, the loom level for S2 is already our baseline. We're going to make everything else conform to the S2 loom level, luminosity level. By the way, when this is finished, you're going to see something that I could have pointed out with the HA data, but as soon as this is finished, I'm going to show you something about my stars that I don't know how to fix. And so I'm reaching out to any of you guys who have some suggestions. This is now an unstretched image, and when you see an unstretched image and you have all of these bright stars, you can pretty much count on these stars being oversaturated. And when they're oversaturated, clip to the point where you can't add color. They're just going to look like this. So I've clipped to the point where there's no data there. So and that's because I'm taking long exposures in order to pull out the data in narrowband, and by taking the long exposures, I'm oversaturating my stars. So there's ways to better or improve that, and I'm in need of knowing how. So for those out there that have suggestions, be it adjusting the gain or the offset, or if it's even in the processing of these images, I would like to know. So let's go ahead and stretch this. And now we have all three of these stretched. Let's bring up our histogram transformation, and I'll show you what happens. So this is the S2 data. Now let's look at this spike. Just keep an eye on that. And then I'm going to bring up the HA, and you essentially have the same spike. And we're going to bring up the OIII, and you essentially have the same spike. So with some modest changes, we have conformed the luminosity and equaled it out on all three, I call it channels, but on all three colors, the HA, the OIII, and the S2. So again, we won't need this for a while. So I'm going to bury that, and we will bury the linear fit, which sits over here. Usually do this after I've done my linear dynamic crop, but when we come back, we're going to use the dynamic crop, and that will be in part 5, and I will see you then.